In class today, we did a scenario where we tried to figure out where to place a mall in South County. All of the strategies that we use are used with the idea of concurrency. Now, I wouldn't take the time to write down this definition, but it's important to know what it means. Concurrent just means that 3 or more lines meet at a single point. It's easy for 2 lines to meet at one point, but for 3 or more to meet at a point, that makes it a little bit more difficult. When we're dealing with triangles, some of the lines that we might use could be medians, perpendicular bisectors, angle bisectors, and altitudes. Now, I highlighted perpendicular bisector and angle bisector because we actually use those today. Tomorrow in class, I am going to show you medians just to show you what the medians are because it's something that's very important as we go through things in life. What I'd like you to do today for notes is something a little bit different. I would like you to create a double bubble. Remember, double bubble shows comparing and contrasting the incenter and the circumcenter. Now, if you notice on the differences side, I do have 4 branches. That's because there are 4 facts that are different among each of the 2 concurrency things. At the end of the video, I would like you to think about what do they have in common. Right off the bat, I can tell they all are a point of concurrency because that's what we're talking about. So we're going to first start with the circumcenter. You may again want to pause the video and take a look and write this down before we get started. The circumcenter is formed by the perpendicular bisectors. The circumcenter is the center of the circle that circumscribes the triangle. When we go through and actually look at some specific pictures, then you might be able to see a better idea of what I mean by that. I'm going to go ahead and fix that in my type since I had the wrong thing there. Circumscribe means to go about something. Just like circumference for a circle is the outside of the circle, that's what the circumscribe means. The circumcenter is equidistant from the vertices of the triangle, and it's the location of that point can vary depending on the triangle. So let's take a look at some pictures that talk about each of these 4 statements. If you would like to go ahead and record them, feel free to do that first, but please continue to watch so I explain what they are. If we're looking at this picture here, in the middle I have a triangle, and I have point G. Point G was formed by perpendicular bisectors. So all the highlighted lines were the perpendicular bisector of each side. They're at a right angle, and if you can see, they marked that the 2 sides are the same. When they intersected at one point called the circumcenter. The circumcenter is formed by the perpendicular bisectors. If you notice, I made a circle from the outside, and what I used is I used point G as the center. And if you notice, the circle perfectly hits all 3 corners of the triangle, meaning it circumscribes the entire triangle. Now, the triangle that I've given you here is an acute triangle. Remember, an acute triangle means all the angles are acute. There's no right angles, there's no obtuse angles. But if the triangle were to change, the location would not be on the inside necessarily. So we'll talk about that in a second. First, I want to talk about how this point is equidistant from the vertices, meaning the corners of the triangle. I used the smartboard ruler, and I found out that 3 2/10 centimeter was the exact length of every single piece. So this proves that G is equidistant to each of these vertices. Again, this is an acute triangle, so the location is inside. Let's take a look at what happens in an obtuse or a right triangle. In an obtuse triangle, the point is located outside, and if you notice, it's outside across from the biggest angle. If you look at the right triangle is right on the hypotenuse, which is the side of the triangle across from the right angle. The next point we're going to talk about is the incenter. The incenter is formed by the angle bisectors. It's the center of the circle that's inscribed. Remember, circumscribed was around the outside, inscribed means the inside. That point is equidistant from the sides of the triangle, and the location of this point is always inside no matter what triangle you have. The way I remember this, in, center, inside. Very easy. In, center, inside, inscribed. All those words start with in. In this picture, and it's a little hard to see, from each vertex there is a ray that bisects the angle. So it's formed by the angle bisectors. Again, it's always inside. So in this particular triangle, it appears to be acute, but if it was obtuse or right, it would still be inside. If we take a look, the yellow section, where I also marked a green tick mark, all of those are exactly equidistant from the sides of the triangle. What I would do now is I would take a minute, I would think about what could be the similarities between these two, and think about if you can come up with a way to remember these facts. I'll share with you tomorrow some things that I've said, just like you heard me say incenter, inscribed, inside, and a couple other tricks that students have come up with.